Hi guys, welcome back. We're kind of finishing up activity 24.2 here. I wanted to go over 6 and 7 real quick, at least the applied version of it. Just to make sure you're getting your drawings, make sure the Pythagorean theorem part's working for you. So on 6b, it actually asks you to solve for the radius of the circle that they're talking about. They tell you that the chord is 12 long and then it's 8 from the center. And so the 12 would be kind of this whole length, and half of that 12 would be 6. 8 from the center goes here, so you've got 8 and 6. You do 8 and 6 in the Pythagorean theorem, you get your radius is 10. 7, exact same idea. The 15 is going to go on the outside, and you're going to cut that 15 in half and get 7.5, and then it's 9 from the center. So for your theorem, you use 9 and 7.5. Whenever I get a decimal measurement, I don't really worry about reducing radicals at that point. It's like, okay, we're in decimals. We'll go ahead and take a decimal answer. So if I do Pythagorean theorem on that, I get 11.7. Now the tricky one with 7 is they don't ask you for the diameter. You have to be careful with that. You have to make sure you read the problems. They actually ask you for, they don't ask you for the radius, they ask you for the diameter. So you need to double it, so you're going to get 23.4 there for number 7. Hopefully that checks out and matches what you have. Now, let's talk about the last theorem that's in this section. This is kind of a drawing to represent it. And what it's going to do is it's going to show that when you have two chords, okay, two chords that intersect each other inside of a circle, the product of the parts of those chords are going to be congruent to each other or equal to each other. What do I mean by that? Well, whatever this length is right here, okay, times this length. So AX, which would be this length, times XB, which is this length, is going to be equal to, equivalent to, this length times this length, okay? And I went ahead and put in some imaginary make-believe numbers here so we can see how this works. If, let's say this length right here is 6, and this length is 6, that's what I've got listed here, and then CX is 4, if I put a 4 up here. This rule right here states that if I have 6 times 6, that's going to have to be equal to 4 times what? Well, what's 6 times 6? 36, right? So 4 times what number is 36? 9. So that means this length has to be 9. That means this is a 9 right here, because technically they have to be equal to each other. Hopefully that makes sense. It's pretty straightforward. It is in your book. We're looking at page 343, and there is an example there to show you as well. This is not a complicated idea. I want you to take what you did in questions 6 and 7, as well as this new information, and the assignment I want you to work on is actually going to be on page 300 and starting on page 343 through 344. We're actually going to do numbers 10, 12, 13, and 17. Let's say 10 minutes or so. Come back, I'll run through those for you, and then we'll look at some new information, okay? Hopefully that makes sense. As always, guys, if you have any questions, my email is down here. This is james.williams. The J is kind of fading. I have to redo that, but it's james.williams@fwisd.org. Thank you.